All right, folks. Today we're looking at imaginary numbers, okay? Simply put, an imaginary number is the square root of negative numbers. Notice I said square root of negative numbers, okay? So we're going to be looking at stuff like the square root of negative 169, square root of negative 75, square root of negative 169, so on and so forth, okay? And then how do we handle it? And some rules that we have to know. I is called the imaginary unit, okay? I is called the imaginary unit. I is equal to the square root of negative 1. Okay? That's how come when we do all of our algebra problem, we never use the letter I, because that's saved for the imaginary unit. So when someone asks you, what does I equal, you just say square root of negative 1. That's all that it means. Someone a long time ago said, hey, let's make I equal to square root of negative 1, and everyone agreed. Okay? All right, so now, this is what when we looked at simplifying radicals, remember we talked about this. This is only for real numbers. The square root of a product is simply the square root of A times the square root of B, or going the other way. Remember, this goes both ways. So I can multiply two radicals, and I just have the radical of their product, the square root of their product. Okay? So we have to use this in order to answer these questions. But this is only for real numbers. The square root of a negative number is not real. It's called imaginary. So what happens is the following. The very, very, very first thing that we have to do is pluck out the I. So rules number one is we're going to factor the square root of negative 1. So we literally write square root of negative 1 times the square root of 169. Okay? And then we would break down the square root of 169, and we could call this I. The square root of negative 1, we just write down the letter I. Times, and lo and behold, 169 is a perfect square. What is the square root of 169, anybody? All right, that's 13. So we don't write I times 13, we just call this 13I. So as soon as you see the I, we know it's an imaginary number. Okay. All right, over here, let's look at this one now. So the very first thing I'm going to do, put my two radicals down, two square root symbols down, and that's right, I'm going to put my negative 1 times 196. And guess what? I did it again. 196 is a perfect square. That's right, it's 14. Okay, and then times, and the square root of negative 1, we just call that I. And so we don't write I times 14, we say 14I. Okay? It's that simple. So your rules are exactly the same when we simplified the radicals, except the very, very first thing that we do is we pluck out the I. We pluck out that square root of negative 1. All right, let's look at square root of 75. Negative 75. So the very, very first thing I'm going to do is pluck out that negative 1. Square root of negative 1. And now 75 is not a perfect square. So what I'm going to do is get my two radicals down. And you know what, I'm running out. I'm going to write it larger. Okay? All right. So now we got to remember we have to do our list of perfect squares. So what's that perfect square that goes into 75? That's right, those lists needs to be memorized. All I'm using numbers is 1 through 10. Okay, so 1 squared, 2 squared, 3 squared, 4 squared, all the way up to 10 squared. Okay, I threw these in. Okay, I think on your homework you're going to see an 11 squared and you're going to see a 12 squared. So you're going to see 121, you're going to see a 144. You'll be able to do it. Okay, all right. So that's right, we need 25 times 3. So the square root of 25 is 5. We leave the radical 3 alone. And the square root of negative 1, we just call it I. So we don't say I 5 radical 3. We write 5I, then the radical 3. Guys, I is just a variable. It's a special variable. That variable has something unique attached to it. I is square root of negative 1. Okay? So, again, 32 is not a perfect square. So, I'm going to pluck out that -1, square root of -1, times 2 radicals. This is going to be my perfect. So what's the perfect square that goes into 32? That's right. We want the biggest one, not the smallest one. So don't say 4. We want 16. 16 times what? 16 times 2. So this is your I. Square root of 16 is 4, and then we leave radical 2 alone. Okay, now just write it proper. 4i radical 2. That's it. That's all we do. Uh-oh, I used a big number here. Uh-oh. It's 108. It's not a perfect square, so there's your square root of -1 and your 2 square root symbols. Look at your list. What's the biggest perfect square that goes into 108? That's right. Hopefully you'll say 36. 36 times 3. And, right, and square root of -1 is your I. Square root of 36 is 6. And square root of 3, which is leave square root of 3. So we simply write 6i radical 3. Okay? Okay. Now let's look at number 6. Number 6 is different. Okay? Number 6 says the square root of -2 times the square root of -12. I cannot just multiply these together, because if I just multiply them together, that product is only for real numbers. This is not a real number. This is not a real number, so I cannot multiply them together right now. We still have to follow our rules. We have to factor out the -1. So this is saying square root of -1 times the square root of 2 times the square root of -1 times the square root of 12. We cannot multiply square root of -1 times square root of -1 together. We have to call it I. So it's I times radical 2 times I times radical 12. Okay? From here on out, you're not going to see me write square root of -1. I'm just going to put I times square root of 2. I'm just going to write I times the square root of 12. So I'm not going to show this square root of -1 anymore. All right, now, I is a variable. What's x times x? What's m times n? What's n times n? That's right. So this is just I squared times the square root of 24. I squared. Okay? All right, now something unique happens. I squared is equal to -1. Because what happens when we square a radical? That's right, when we square a radical, when we take the square root of -1 and we square it, remember we talked about this before, the radical cancels out. Okay? When you square a radical, the radical cancels out, and then all I'm left with is -1. Okay? So I squared is equal to -1. Very, 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 very important. I'm going to put another star next to it. This needs to be memorized. This needs to be memorized. I squared is equal to -1. Okay? All right. So we know I squared is -1, and we just have to clean up square root of 24. So we have -1, and I have my 2 radicals. So what's my perfect square for 24? That's right, you're going to say 4. 4 times 6. And the square root of 4 is 2. That's right. So I have -1 times 2 times radical 6. So we just have -2 radical 6. Okay? It's that simple. Okay? There it is. I times I. X times X. M times M. N times N. I squared. And then I squared is equal to -1. So we have -1 times the square root of 4 times the square root of 6. That's it. That's all we got to do. Easy peasy. Alrighty. Same thing. I'm not going to show square root of -1 anymore. I'm just going to call it I times radical 6 times I times radical 12. And what does that give us? That's right, I squared times radical 72. So now all I got to do is just clean up 72. So we have negative 1 times, all right, what's the perfect square that goes into 72? Okay, don't say 6, 6 is not a perfect square. Don't say 12, 12 is not a perfect square. 9 is not the biggest perfect square. Okay, 9 is not the biggest perfect square. 36 is. 36 times 2. Remember, we always want the biggest perfect square. All right, so that's right. Square root of 36 is 6. And then we still have our radical 2. And we got the negative 1. So we have a final answer of negative 6 radical 2. Okay. All right, last one. So notice both of these had negatives on them. I still plucked out my i's. I times I is I squared. Look at 8. It's actually a little bit easier. There's not two negatives here. That's fine. What do we still do with this? That's right, we got to pluck out the I. And then, right, we're going to multiply those two. And now I just have to clean up 98. So I have I, square root, square root. What's your perfect square that goes into 98? That's right, it's 49. 49 times 2. And so we just write, I'm just going to write it out because I'm running out of room, 7I radical 2. Okay. That's it. That's all we got to do. There's no, it's not I times I or anything like that. So we just have 7I radical 2. All right. Now, so let's a quick review here. Whenever we simplify these square roots with the negatives underneath them, these imaginary numbers, the first thing we do is we pluck out the I. Okay? Look at that. We plucked out the I and then we cleaned things up. Even when we had to multiply things together, we plucked out the I first. So square root of negative 1 times square root of negative 1. So we had I times I. That gives us I squared. I squared is equal to negative 1. Okay? All right. Now, all right, now we're looking at what's called powers of I. Okay? Powers of I. So we're looking at, we have to simplify, like I to the 17th. Simplify I to the 27th power. Simplify this product. Simplify. Okay? So here we're going to be doing some simplification. Okay? All powers of I can be broken down into 4 numbers. Okay? All powers of I can be broken down to a 1, a negative 1, an I, or a negative I. That's it. All powers of I are eventually going to become one of those 4 values. And we're going to see it with these exponents. So anything to the power of 1, I to the power of 1 is just I. Here I don't need to say square root of negative 1. Okay? We just say I. I squared, you just saw on the other side, is negative 1. Okay? Now, I to the 3rd power. What exactly is I to the 3rd power? Think about your exponent rules. What 2 values, when you multiply them together, would give you I to the 3rd? Right, hopefully you'll say I to the 1st times I to the 2nd. Well, what is I to the 1st times I to the 2nd? So it's an I times negative 1. So I to the 3rd is literally negative 1I. I'm just going to say negative I. Okay? Okay, I to the 3rd is literally I times I squared. Right, we add exponents. You guys have already been adding exponents before. I don't care that this is the letter I. Okay, I is just a variable. It's a special variable. We already talked about that. Okay, so I times I squared. I times negative 1 is negative I. So I have my 1, I have my negative I, we have, no, I don't have 1 yet. I'm sorry, I have negative 1, and I have my negative I. And I have I. I got these three right here. So that means I to the 4th is equal to negative 1. I want to show you how. Think about your exponents. What two values when you multiply together, what two exponents, so I to what power times I to what power will give you I to the 4th. Okay? Well, hopefully you'll say I squared and an I squared. Right. And so negative 1 times negative 1 is positive 1. Why did I put a negative there? There we go. Those are your powers of I. Okay? If you wanted to, you could have said I to the 1st times I to the 3rd, so it's I times negative I. So that would be a negative I squared. So I squared is negative 1, double negative, positive 1. Okay? So these are your powers of I. All right, now how do I clean this up, I to the 17th? Okay? There's a nice little trick that we could do. Okay? Which you're looking at groups of 4. Well, how many of these groups of 4, how many of these groups of 4 go into 17? Okay? So I can just start counting. 1, 2, 3, 4, 5, 6, 7, 8. There's 2 groups. All right? 9, 10, 11, 12. There's 3 groups. 13, 14, 15, 16. There's 4 groups. And here's 17. I to the power of 1. So I just get I. Okay, I know I did that fast, but think about this. How many times does 4 go into 17? And you know what? I don't care how many times 4 goes into 17. I want to know what's the remainder. Okay, so type that into your calculator. What is 17 divided by 4? Okay, what's your decimal value? So 17 divided by 4 is literally 0.25. Okay, that's 1 over 4. Okay, so this in the calculator, so if you do this, divide by 4, here I'm going to write it down here, I'll write it here on the side. So we're going to divide by 4. So you're dividing the exponents by 4. Divide exponent by 4. This is what you're looking for decimal values. If you see a 0.25, then you're going to just say my answer is I. If you see 0.5, 1/2, remainder 2, you're going to say negative 1. If you see 0.75, then you're going to say negative I. If you see no remainder, no decimal, so it goes in evenly, then all you got to say is 1. Okay? So 17 divided by 4 is 4.25. Type that right in your calculator. 0.25, just say I. Okay, so I'm going to put it up right here. 0.25, 0.5, 0.75, no decimal. Okay? All right, 27. That's right, 27 divided by 4. I'll pull out my calculator because I know some of you need help with the calculator. So all I'm going to do is 27 divided by 4. By the way, I know the remainder is going to be 3 because what's the closest multiple of 4 to 27 without going over? That's right, 24. So how many more do you have to go? 3. There it is, negative I. So 27 divided by 4. 0.75. I don't care about the 6. All I care about is 0.75. 0.75 is negative I. Done. Uh-oh, what do I do here? I to the 6th times I to the 10th. You're multiplying. Like bases, what do we do with the exponents? That's right, we add. So I'm looking at I to the 16th power. All right, so what? 4 goes into 16. What's the decimal? Hopefully you'll say no decimal. It goes in evenly. So if it goes in evenly, no decimal, that's right, no decimal is 1. All right, look, and if you're not sure, 16 divided by 4, see, no decimal. Yes, on my calculator it says point. Yeah, what comes after it? Nothing. All right, last one. I to the 8th times I to the 10th. So that is I to what power? That's right, 18. And then all I have to divide by 4. By the way, I know it's going to be 2, because what's the closest power of 4 to 18 without going over? That's right, that's 16, so remainder 2. Remainder 2 is negative 1. Okay, so 18 divided by 4, 0.5. 0.5 is negative 1. That's all we have to do, folks. That's how we clean up our powers of I. That's just your simplifying rules. Okay? All right, folks. Good luck with your homework.